Hi, I'm Brad. Obviously, this channel has been a pretty big source for Index 2 patent news and really just what Valve has been working on in hardware in general. A few days ago, I asked my community what they thought of me of actually doing another Index 2 video update when a pretty big patent came out. And to my surprise, an overwhelming majority of you wanted me to talk more about Index 2. That makes me very happy, because that just means you guys are as excited about it as I am. What's even better is, since I made that post, a couple more patents came out that are just as big as that one, if not bigger. So due to all these factors, this is one of the most exciting videos I'll ever make. In my hand here are a bunch of pages of patents for the Valve Index 2, or the future VR equipment that'll be put into the Valve Index 2. As always, I read through everything thoroughly, so I have a very good idea of how everything works. I do not use scripts because scripts are lame. Now, I believe there's a lot of big factors to what makes a VR headset or any VR hardware good. I think the most important thing that a headset has to get right before you can even sell it or let it be popular in a VR market is it needs good tracking. You can put some amazing displays and some amazing other technology inside of it, but if it's not tracking well on its own, what's the point? You're not selling a TV to people, you are selling a VR headset. In a couple of my last videos, I was talking about technology that Valve was working on and was showing in patents. Well, today we have a patent that actually shows that technology maturing to the point where it's actually a big deal and probably will come to market very soon. The first patent talking about this optical flow technology was to allow the next index to not need base stations if a user wanted to, have inside-out tracking without markers. The benefits of that obviously is overwhelming for people that don't want to drill holes in the walls or have these tripods and have good tracking. Good tracking is something key to what I'm about to be talking about here. But in that original patent, they only talked about this system really just for the headset. There was no mention of controllers or how new controllers would be tracked by this system. Well, today, not only do we get a big update on this optical flow tracking system, we get literally all the nitty-gritty details of how it'll work and how other components will be able to use it. Mostly controllers. The best way I'm going to describe the system is first to give a visual aid or visual example. I'm going to take this 3D model of my dog off of this Lighthouse space station, 1.0 to be exact. So Lighthouse tracking is an example of markered inside-out tracking. It is not actually outside-in tracking because all the actual tracking data is computed by the unit in the headset. It's not the Lighthouse sensors that are doing the tracking computations for tracking. I know it's confusing, but stay with me. Anyway, these things are just emitting pretty much laser sweeps and IR, infrared light. In this first iteration, you can see these two spinning parts here. These were the motors that allowed the laser sweep to sweep at a certain frequency or speed. Due to the fact that these are constantly spinning, people with Lighthouse complain of a slight whine noise in these things. Not only that, these things are very prone to failure because of the fact that they're constantly spinning. It's very similar to an old hard drive. Hard drives were known to fail too, and when we switched to solid state drives, that solved a lot of problems because there's less moving parts at all times. Lighthouse 2.0 improved on this design by making one less motor and making the FOV range a bit better, while also allowing the lighthouses not have to stare at each other in order to work effectively. Now, the benefit of this system compared to a lot of other inside-out tracking methods was there was generally no occlusion, so things such as having controllers behind your back were still actually being tracked at all times because there was constantly a laser sweep that these components were able to track by themselves. However, once the player in VR would leave any of the range of the Lighthouse space stations, you couldn't actually play VR. It was reliant heavily on these laser sweeps and IR. So basically, a standalone headset wouldn't really be beneficial, first of all. Again, standalone, for those who do not know, are headsets that do not need an output processing unit. It's all built-in hardware directly on the actual headset to run everything, like the Quest 2. In my previous videos, I talked a lot about how a Index 2 might have a compute unit, most likely at some point, whether it be built in directly with all Index 2, or later on a compute unit that will allow Index 2 users, and Index 1 possibly, to upgrade to full standalone features if they want to. However, if they were to stay on the current Lighthouse system, there's no benefits to having a standalone headset. If you cannot bring it anywhere you want without setting up Lighthouse space stations or things on a tripod, it's not as reliable or really accessible. So it was very important for Valve to come up with a new system for tracking, and this optical flow system, which actually is kind of detailed, it's something different. And this, they call it a position tracking system for head-mounted display systems that include angle-sensitive detectors. A big thing I want to mention is this system that I'm about to explain fully still actually will work with Lighthouse space stations. There's a huge benefit to Lighthouse space stations, and these sensors will still work with Lighthouse. Because while this system will be very good and very powerful at high refresh rates, there's always a benefit to having markers that are emitting laser sweeps. So how would a standalone headset or a headset without markers work on this new Index 2? Well, Valve has basically decided, if we can't have lighthouses, but we want very interesting, accurate tracking, what if we make the headsets and controllers emit sort of their own lighthouse? That's basically the best way I can put it. Now, I do not want to confuse anyone. This is a very bare bones way to explain the technology in this patent. We see these little lights here being emitted on the sides. Well, imagine this is sort of like the IR frequency being emitted by the lighthouse. Basically, just plop this thing on there. Again, very bare bones explanation. But obviously the big benefit of being able to do this is the controllers, which will have these new type of sensors, will be able to detect the emitted light, and it is light, from these headsets. Not only that, Valve also mentions that the same kind of concept will be implemented for the new controllers as well. We've really not seen much of any information about the Knuckles 2.0 or Knuckles V2 or whatever you want to call it, and that was kind of a big worry for me because you need new controllers if you are going to have a new tracking system. And the way that they're getting past the idea of having this system be able to track is they will plan to have these IR or these LED or light rings or something like that emitting light from the controllers themselves. So not only the controllers and the headsets will both have their own light source giving off light, but both the headset and the controllers will have these new sensors that can not only work with Lighthouse space stations, but also work with this new light emitting system. I also want to remind everyone, for those who did not know about the optical flow tracking system I discussed in my earlier videos, which is pertaining to this new tracking system has a refresh rate of 1,000 up to 2,000 hertz. That is insane. So really, this is a very high fidelity, markerless inside-out tracking method. Not only is this high refresh rate tracking data good for obviously very high accuracy tracking, especially when they add the machine learning, which they also detail in the patent to make it even better, or at least the data much better. This is also very useful for a system they seem to be working on, which is sort of a high refresh rate tracking prediction system. Basically, with the more tracking data you have on a headset, the more that you can tell the computer or whatever compute unit you're using to start rendering frames in advance based on what the computer thinks the user will be kind of moving in advance. So let's say you're moving your head a lot for this one scene, the computer can start deciding, hey, this tracking data is pretty reliable. Let's start rendering these parts of the scene like ahead of time. And at the same time, let's also start illuminating the actual pixels in the headset as well. So this is very useful for improving not only just the rendering compute power, but a few other things. So it's basically a very hybrid tracking system. I also wonder if this sort of hybrid use is going to allow us to see a new type of base station for users that may want it. I said that the current Lighthouse 2.0 uses one motor currently spinning, and it makes me wonder with this new system, which again just uses light without really any laser sweeps, could we see a solid state base station with no moving parts to allow less failure rates and maybe better tracking? Who knows? There's also a huge silver lining as well with all this new tracking system. Valve is clearly going for more of the enthusiast tier or above with the next headset. I would be very surprised if it's not around the same price point as the current Index stands right now. I know a lot of people want it to be cheaper, and we might see some subsidization from Valve, but there's a lot of things in here that they're putting that sound pretty expensive in terms of tech. And the subsidization might be purely to make a very expensive headset go to more the enthusiast range still. But with this new tracking system, I imagine Valve will actually start working with third parties that people that want to build their own headsets or own accessories will be able to use this new tracking system for their headsets. Maybe these people want to target maybe the lower tier or like, sort of the more consumer friendly or less enthusiast level hardware and implement this tracking system in theirs. Well, they can. Or another thing is maybe they want to actually have accessories for this new unit, like new full body trackers or whatever that they might want. I really see Valve really pushing this technology to other people, just like they tried to do with the Lighthouse space stations and the Lighthouse tracking sensors that we have and everything, including like Vive trackers. But it just ended up being too expensive to implement for a lot of these hardware manufacturers that are trying to make a profit because they don't have the reliability of making software sales from a Steam store. A lot of that could be conjecture or just my thoughts on things, but I really do think there's some value in this new tracking system, not just for Valve. I know it's very long, but really I think tracking is very important, so I wanted to spend a long time talking about it. I may have lost some people. If I did lose you, I'm sorry. But let's continue on to some of the next features. I've been saying for a while that the next index will definitely have eye tracking. And it will. 100%. And we got a patent detailing the exact technology they're using to be able to track your eyes, your eyeballs, your pupils. It's actually a very different technology than what we see in the Vive Pro Eye or the HP Reverb G2 Omnicept. They use the Tobii eye trackers, which they do give off a IR light around the rings of the lens, but the difference between this one is this is using a camera to kind of capture what the pupil's looking like with those IRs blasting into their pupils. Valve will be doing something different. They will be emitting light into your eyeballs, but instead of using cameras to capture what is looking like light in your pupils, because, even my eyes right now in the camera, you can probably see my studio light in the background. That's kind of how the current tech works. It'll be using photodiodes or just simple light sensors to accurately guess the reflections and where the eyeball and pupil is, because your skin, your blood vessels, the whites of your eyes, and your pupils all give off different reflections based on the light they plan to use. I know you're already thinking, well, that kind of sounds pretty painful. They're emitting light in your eyes. Well, first of all, it's invisible light. You will not notice it, and they also have polarizers to make sure it is totally safe and you will not have any discomfort. Again, I use the Vive Pro Eye, and it uses very similar technology, just with a camera. And eye tracking is incredibly important for VR. I've been saying this for a while. This new technology will probably allow a much more higher refresh rate in terms of actually eye tracking quality. The current eye tracking quality has been complained about for foveated rendering that it will not be able to give significant gains due to the latency of eye tracking. Well, if you remove the camera and just have simple light sensors that are predicting and accurately predicting ahead of time your gaze, then it actually makes foveated rendering technology a lot more useful. Not only that, is eye tracking also allows you to do things such as calculate your IPD. And why is that important? Well, a lot of the recent patents have actually been mentioning something very fascinating. We haven't been seeing this except for some of the newer patents. All these patents I'm talking about today were patented or at least submitted for patent in January of 2020. Most of the other patents I cover on this channel were around September of 2019 submissions. So these are all sort of the progress that Valve has been making to all the current technology that'll be in the Index 2, and it's all very much maturing. And in a lot of these newer patents, we're seeing a strap system that has automatic motorized straps to make sure that the headset is constantly in the sweet spot of your zone. Due to the fact that this eye tracking technology really requires perfect precision for your eyes to be in the center of the sweet spot, except for not reasons for clarity, but really just for the eye tracking to work very accurately. Valve must have realized that when people move their head a lot, that the headset shifts a lot. So they decided having motorized mechanisms inside the strap will actually allow the headset to stay in place comfortably for long periods of time. This also helps to make sure that no light bleed gets in the headset because, again, since these are just typical light sensors, it'll be very important for this type of light to be reflected back accurately without any outside sources kind of getting in the way. So that's a cool feature. I never would have thought of motorized head straps making things not only just the most comfortable, but also things for making sure you're at your sweet spot for clarity and for eye tracking to work at its best. Eye tracking also allows other technologies such as being able to fix sort of artifacting in displays. A big example of that would be pupil swim, which is sort of like when your eyes are moving fast, the lines start to kind of stretch and bend. With eye tracking, renderers will be able to accurately fix stuff with that in some displays. The patent also goes in to talk about stuff such as saccadic masking, which, if you don't know what saccadic masking is, when your eyes are moving around super rapidly, your brain, this is a very strange way to put it, but your brain is actually not rendering your eye view until your eyes are kind of stop moving. So Valve was thinking to themselves, well, our brain already kind of stops rendering cheaply when our eyes are moving fast. Can't we let a computer do that as well when our eyes are moving incredibly fast between the screen? So not just foveated rendering, but taking advantage of that alone will make things run much better. I don't have much more to say about eye tracking, but really, VR cannot actually improve. VR hardware cannot improve without eye tracking. There's a lot of concerns that eye tracking technology gives, and I really don't want to talk about it because it depresses me heavily, and we have big actors such as Facebook getting into eye tracking for really nefarious reasons. But at the same time, the technology just is going to exist for VR. It's impossible for VR hardware to improve without it. Now, a few final little tidbits in the patents I've been reading recently is stuff such as making the new Valve Knuckles controllers a bit better for hand tracking, using sort of things such as group sensors. The current issue with the Valve Index Knuckles is they only allow you to kind of track your fingers being open or closed. You can't do stuff like this. Well, with some new group cluster sensor arrangements and some other algorithms that they're working on, it seems that the next Valve Index controllers may actually allow you to do this. Which, it's a small thing, but it's nice. Another thing is this patent actually talks about refresh rates up to 180, quite a few times actually. So it's very possible that the next index will have a refresh rate of up to 180 hertz. Higher refresh rates will obviously be very beneficial for VR because as it gets better, things such as motion blur will not be as sickening, and just generally raising refresh rates is good for first-time users who are not used to VR because it makes it feel a lot more natural until we figure out a way to solve the motion sickness problem, which is still a problem for a lot of people. Finally, one more small tidbit. I'm not sure if it's really worth to notice, but in this patent, they only mention OLED displays in the eye tracking patent, where generally all patents before it were actually talking about a bunch of different displays being possible for use in the next headset. The fact that they only mention OLED is kind of strange because it really opens the door that this patent only works for an OLED display, or at least the main example for what they're using in the patent. It's very possible we may see an OLED return to VR someday, and this might be a very good chance, or at least hint, that maybe the next index is OLED. I'm not sure fully. I know there's a lot of benefits to OLED, especially color contrast and color reproduction, but there's also some downsides. The biggest issues were screen door effect was a lot more noticeable, but maybe things have been solved since then. At least the manufacturer that Valve may be looking at. So if you're a fan of OLED, you love the Vive Pro because of its colors and the blacks, well, maybe it's a good thing. But that's pretty much everything I have for these new patents and all the new stuff that this Valve Index 2 might have. People have been asking me in every comment video, or really every video I've been doing about Index 2, when I think this headset will come out. Again, this is speculation, but I really do believe we'll see the Index 2 next year. Whether or not it will have a compute unit with it or not, I do think we'll see new VR hardware from Valve next year. Everything just seems to be aligning to that, in my opinion. We're probably seeing stuff such as SteamVR 2.0, and we had the Steam Deck announced, which really gives a big hint to what Valve is targeting for future hardware. Not only just improved thumbsticks, but really a whole software platform that allows the entire SteamVR library to run on portable hardware, which will be beneficial for VR too. Anyway, I hope this was a very good video for you. I hope it makes you excited, not exhausted, because I know I talked about a lot of things, but really, I'm trying to do my best to explain how things are working in the current PC VR enthusiast market. If you like the video, please like it, subscribe, show your friends. PC VR is a weird place right now, especially hardware. And I think it's very healthy for people that are very big VR enthusiasts to be excited about the near future of VR hardware. So that's why I do these videos. But yeah, I hope you have a great day, and bye!